Hey chaps, and welcome back to the MonoGame RPG project. Last time out we created an editor project and an engine project whereby we could share code between the two, and successfully did that with our map code as well. Today we're going to be primarily focusing on increasing the functionality of our editor so that we can use the right mouse button to navigate around, and also use the left mouse button to click on the tiles and change their color as well. So without further ado, I'm going to open up Visual Studio. We have our editor project still highlighted as the default, and if we hit start, we'll see exactly as we left him before. Okay, so what we're going to do today is change the color of these tiles by default so they look a little bit more different, and also be able to navigate around and click on them. To do that, we're going to introduce the tile class. So if we right click on the engine project, add new item, and now we're creating this class in the engine so that it can be shared between the two other projects, and also we can change and manipulate them from the editor as well. So we'll call that tile. Now if we change this to public, like I say, we need to access him from outside the engine, and he's going to have one property, and that is just the color, which is going to represent the background color of the tile. We'll have some complaints about namespace here, so if we control period enter. Okay, and that's pretty much all there is to it for our tile class really. It's just going to have this one piece of information. The main change is going to be in the map and the control itself. So we can close the tile now, head over to our map, and you see before we've got a width and a height, and we use that width and height just to arbitrarily ditch a load of black tiles onto the screen. We're going to be changing this up slightly now. So we're going to introduce some use of our tile here. So we're going to private tile 2D array, call it tiles. Now the point of the 2D array is so we can refer to the X and the Y very quickly. The downside to that is we have to go creating them, of course, which we'll do right now. And as a result, we'll also be able to remove the width and the height because we can get that same information from here, which you'll see shortly. Okay, so to start using it, we need to create the instance of our tiles array. So tiles equals new tile, and like I say, this is so we reference the X and the Y quickly. So there's a two-dimensional array, the first dimension being the X or the width, the second dimension being the Y or the height. So in our square brackets we'll create width and then height. Now as it stands right now, this is an empty array of tiles. We can't use any of this information, we need to populate it with the tiles. So we can kind of reutilize this nested for loop structure down here. We'll copy that and put that up here, and we'll just remove the content of the inner for loop there. Okay, so it's very easy just to fill this in really. We've already got the information here. We start at 0, work our way up to the maximum width, start at 0 for the Y, and work our way up to the maximum height. We just need to fill in the tiles. So if we do tiles equal, or rather tiles X, Y equals new tile. And that's it. We've filled in our array of tiles. Now they will have a default color of white, so when we start using that information it will be white. So what we can do is initially just change this to red. So we'll do this here, put a square brackets on there to set some default properties, or curly brackets rather. We'll call this background color equals color.red. Okay. So if we hit start here, nothing's going to look any different. We've created our tiles, we've set our default color for them, but we're not using that information yet, and that's what we need to do next. So if we head down to our draw functionality down here, we've already got this loop going on here, this nested loop system where we're starting at 0, working up to the width, same thing we do up here, and that's for drawing each individual tile. The only thing we need to do here is pull the information out for each respective tile as it's about to draw it. So if we create a tile variable, and this is really simple, and this is why the 2D array system is very useful. So tile equals tiles X, Y, and it's as simple as that. We now need to use the background color of this tile here instead of black. So we could just remove this black here and use tile.background color. Okay, if we hit start now, we should, in theory, see a load of red tiles, which is perfect. So we're now using that new tile class to drive how each tile looks, and each tile can have a different color. So we've given that extra layer of depth already. So if we close this guy down, what we're going to do here is I'm going to change the code slightly here to use a modulus, just so we've got alternating red, greens. So we'll choose X plus Y, modulus 2 equals 0. We'll have colour red, otherwise we'll have colour green. I'm not going to cover how ternaries work, so if this looks a bit alien to you, I won't worry about it too much. I can cover things like that in a separate episode, more specifically C# rather than MonoGame. So if we do that and hit start, we should have a pretty checkerboard pattern of greens and reds rather. Okay, so with that said, there's some tidy up we can do in here. As I alluded to earlier on, we don't need this width and height anymore. We can pull that information from here. So what we're going to do is we're going to delete these two variables here, and we'll get some complaints obviously because we'll be using that information around here. We can remove setting them here, and then down here, how do we get the width, how do we get the height? Well, it's relatively straightforward again. So like I say, to get the width of the tile map, we just need to pull out the size of the first dimension, and for the height we pull out the size of the second dimension. Okay, so if we use tiles for the width, get length 0, obviously this is 0 index based, so that is the first dimension, and then for the y, tiles get length 1. Okay, so we've now changed how we draw stuff. We changed it to reference a completely different width and height. If we hit start now, we should end up with the same 10 by 10 grid that we had before, which we do. So that identifies that that is working correctly. Okay, so we've changed the code here to use tiles get length, here to use tiles get length. We haven't changed it up here, which I'm still actually going to change. We don't have to change it because we have the width and the height here handy already, but I'd like this loop to be driven by the size of this as well. So if we change anything, we only have to change it in one place. So if we just put the same information in here, tiles get length 0, tiles get length 1, and again give it a quick run, and we should end up with the same result, which is good. Okay, perfect. So for the map, that's mostly it for now. We'll revisit this class shortly when we need to. For now, we're going to head back to the editor. So we'll close this map class for now, collapse the engine project, and head over to editor. And we want to open up the editor control that we created in the last episode. Okay, so what we're going to do here now is start introducing some input. So we can start dragging the mouse around and actually clicking on tiles to change how they look. To do that, we're going to use the MonoGame extended input library, which requires us to obviously import that library using NuGet, which we'll do right now. So if we right click on the editor project here, manage NuGet packages, and then for browse, we've searched for MonoGame extended, and we should find our input library here. So 370 install. Okay. And that will now expose some additional nice stuff that we can use in the editor. So we close this down, head back to the editor. Now you'll remember in the game project we created quite early on, in the game class there is an update method where we do all our input changes and then changing the camera as a result. So if we go back to the control, we need to also override this same method. So if we head back to the control here, override, spell override, update, enter. Okay, and now we have our update method ready to go. The first thing we need to do is get the state of the mouse and store it. Now the reason for that being, I'll explain in a little while, but trust me, we need to do this first. So if we get our state private, so it's called mouse state extended, I believe. Call that mouse state. Yep, there it is. Okay, so we've got our mouse state there, and the first thing we need to do in here is actually get that state from the mouse. So mouse extended, if I can spell. Okay, so that's the first thing we need to do. Unusually, this is called mouse state extended, and this is called mouse extended. For things like the sprite batch, MonoGame extended just use extension methods, so you just get them as part and parcel of the sprite batch. I'm not sure why they've taken this approach. I don't know if there's any history behind that, but that's just the way it is. So it is a little bit unusual because in the normal game you'd just be mouse state and mouse basically. So this is a little bit of a nuance. Be aware of that. Okay, so the first thing we're going to do is just show you guys how this works. Is we're going to put a little if condition in here, and we're going to check for if mouse state was button just up, and we'll use mouse button dot left. I'm going to stick a little debug right line in here just so you can see how this behaves. I just clicked left. That's going to complain about namespaces. There we go. I don't really want to import the whole system diagnostics namespace, so I've just prefixed this. So what will happen now is if I hit start, you'll notice down here when I left click and release, I just clicked left. And if I do the same thing again, left click and release, and there you go. So that's just the action of clicking and releasing, not just clicking down. And that's what we want really for when you're changing the tiles. For now, we can change that later on. It's just so it doesn't frantically try and change loads of tiles as you're dragging around, or try to change the tile too much too quickly. So if we close that down now, that's how this code works. And the reason we actually store the state here is because every time you use this, it stores the previous state, and that's how it knows if the button was clicked and then released, and that's required for this behavior to work. So that's why we store this state. Okay, so you may or may not be aware if I open the project again. So as I said, if I click and release, I just click left. The problem is if I click in Visual Studio and release, it still happens. If I click on my, I don't know, if I click on my taskbar, does it happen there? Click and release, it does still happen. Wherever I click, it's still capturing the input and still falling into here. So even then when I drag to highlight, it still happened. We don't want that to happen because if I'm in Visual Studio editing and I've got the project running in the background, I don't want it to be responding to my input because that just does not make sense for our use case. So we have to be a little bit more defensive around our input or an update behavior. So if we close the project down, so this is relatively straightforward. If we store what is called the form in our editor, we'll have some namespace issue there. And then if we get the form, so if I use form equals find form, okay, and then straight after our base update, if we use if the form does not contain focus, and then we simply return. Okay, so what that means is if the form itself or nothing within the form has the focus, then we just simply will not perform any of this update logic. So if I hit start again, if I left click in the window and release, there it is. If I left click in the window and release, there it is. If I click around just outside the window and release, there it is. Now the theory is now if I left click and release in Visual Studio, as I am doing, click and release, it's not responding, which is perfect. That's exactly what we want. So that's actually a really important piece of code there. It might look a little bit unusual, but it's required if we want this sort of behavior, especially if we do not want our program to respond to clicks outside of it as well. And the same thing will apply to everything in here, not just the mouse clicks, it's everything. Okay, so we've had our defensive code there, which is perfect. I've showed you how the clicking works and how we can get that to output down here. What we're going to do next is we're going to make it so when we right click, it will drag around the map, around the camera so we can navigate. So this is relatively straightforward. We just have to change what we do here first. So we check if is the button down, and we change this to the right mouse button. So I want to use the right mouse button to drag around. It's kind of like RPG or RTS-esque. Just feels quite natural to me, so that's my preference. You guys can change this however you want, or even get a bit more creative about how you do it. If you want to hold shift or something like that, you can experiment with that. That's also fine. So what I want to do here is change this now to do something a little bit different. So what I'm going to do is I'm going to get the camera from the map, and we're going to move it based on how far the mouse has moved. Okay. So the first problem here is I've spelt that wrong, uppercase. Okay, so the first issue it's going to complain about is it's expecting a vector2, but actually the mouse has a point. MonoGame Extended has a lovely extension on the points class where you can just call .toVector2, and that'll turn a point into a vector2. So that's all you need to do there, nothing else more than that. Okay, so if I just get rid of that debug outline now, okay, and give that a launch again. Now if I right click and drag, we've got some beautiful right click drag navigation there in there now, which will really help us moving forward to navigate around our tile map. Eventually we could have things like zoom in there, so we can scroll around much quicker, but that is a really simple and nice way of navigating around now. Okay, so that's our navigation done. The next thing we need to do is change it so we can left click on a tile and actually change the color of it. Okay, so what we're going to do here is we're going to have an else if in here. So if we're left clicking, so if mouse state, much like we had just a second ago, was button just up, and we're going to change this to left. So this is pretty much the same condition we had a second ago, except you can only do one or the other. You can only navigate or be changing a tile. That's the idea. So the first we need to do is get the mouse position. Okay, so note that I'm getting the position and not the delta position. The position is where it is in the screen rather than how much it has moved between the last update and this one. That's what the delta position is. So this is just getting the absolute position of the mouse on the screen. And additionally, what we need to do is convert that screen space to world space. Now obviously, depending on where we're looking at a map, so if I leave this as it is here, 0, 0 in the world is still 0, 0 on the screen. However, if I move this around, this top corner is still 0, 0 on the screen, but this is 0, 0 in the world. So we need to always make sure we're converting from where we're clicking on the screen to where we're clicking in the world, especially when we're interacting with the world. Because if I click on here, we need to make sure it's still considering that tile here and not when it was up here. Okay, so to do that, it's relatively straightforward as well. The camera has some very helpful utility methods for doing that. So we can get the vector to world position, my map, camera, screen to world, and we'll just use the mouse position. Now again, this will complain that it's expecting a vector 2 and not a point, and that's where the helpful utility methods come in for converting to a vector 2. Voila. Okay, so what's the next thing we need to do? Well, okay, so if we're in, think of it this way, we're in our map editor, I'm clicking, okay, I've got where I've clicked on the screen, I've then converted to where I've clicked in the world, which is here. What's the next logical thing we need to do? Well, we need to get the tile so we can then change its color. So there's some extra calculation we need to do that. So if we close the editor, we're going to introduce a new function to our map class. Okay, so what we're going to do next is introduce a function to the map class which actually converts where we've clicked in the screen to where we've clicked on the map itself. So if we head to our map class in the engine, in here we're going to have a new function called, and it will return a tile, and it's going to be called get tile at position, vector 2 position. Okay, so from our control we can then get a tile at that world position. So this could be relatively straightforward really. We could just return a tile. So if we get a tile out of the 2D array, equals tile, or rather, so on position dot x divided by the tile width, position dot y divided by the tile height. In fact, what I'll do is just to make that a little bit easier to read, is x equals position dot x divided by height, y equals position dot y divided by tile. I don't know why I'm saying tile height on the top one. This needs to be tile width. Okay, and it's going to complain because it's essentially going to convert to a floating point number. We'll just cast that down. Okay, and then in here we'll just return tiles x, y. Okay, remember what I was saying about using the x and the y in the 2D tile array. The reason for this being, obviously, you know, where your mouse clicks is obviously the world space is not the tile space. You need to divide that by the size of the tiles to know how many tiles into the map you actually are. So there's obviously one problem with this right now as it stands, and that is if I click outside of the tile map, either that's like to the left of the tile map, top of the tile map, bottom or right, this will be an invalid number and this will be an invalid point in the array, which I'll demonstrate in a moment. So we can be a little bit more defensive around that. Okay, so if I head back to our control here, we can get the tile out by getting tile equals mymap dot get tile at position world position. Okay, so we're not going to do anything with that right now, but I'll be able to demonstrate here what that does if I click. So if I click here, there we go, we've got an exception because the index is outside the bounds of the array. Okay, so what do we need to do to solve that? There's a few things we could do. We could just return a null in the event that we clicked outside the bounds of the array, or we could just clamp this number so that it's always within the size of the tile map. So the issue with that is if we click on the right hand side, it might change a tile on the very far right hand side, even if we're nowhere near the tile map. So what we're going to do here actually is return a null if it's an invalid point in the array. So there's a little bit of condition checking we need to do here. So if tiles dot, or rather if x is less than 0 or y is less than 0, or x is greater than the tiles dot get upper bound 0, or y is greater than tiles to get upper bound 1, return null. Okay, so you saw previously that we use get length, and that just gives you the size of the array. Get upper bound gives you the last possible index in the array, which is a little bit different. So the last possible index is always the length minus 1 in theory. So considering everything's 0 index based, this is more useful for our use case here. So now if we head back to the project and give it a start, click around a little bit, let's navigate over here, click around over here. We're not breaking anything anymore, which is good. So if we head back to our editor now, one thing we need to do here is if the tile is not null, because obviously we're returning nulls now, what we need to do is change the color of the tile, right? Okay, so to do that, I'm going to leave this relatively straightforward and be kind of simple really, and just do if selected tile dot color equals color dot red, then we change it to green. Else we change it to red. I don't know why I'm saying selected tile. Tile dot color equals color dot red. It's background color. Okay, so let's give that a go. If I hit start now, if I click on a red tile, it turns green. Click on the same tile again, it should turn red. Okay, we can do that with any of them. Perfect. Okay, so what we can use that then for moving forward is once we've got some tile textures, when we click on them, we can plop that texture onto that tile. And then we can use this for some large scale painting as well, so we can paint lots of tiles very quickly. I'm going to leave this code over here quite rough and ready because it's obviously not going to be permanent. We're going to be setting textures, not colors, but it does demonstrate how we can interact with the map, especially when we're moving around as well. So if I move over here and click on this tile, it should still register the right tile no matter where I'm scrolled to, which is exactly what we want. Okay. And that actually about covers it for today. We've made some good progress here on interacting via the mouse in the editor window, by clicking and dragging around, which is really good. Next, I think we're going to look at potentially some more elements around the actual form itself, so we can maybe look at potentially dropping text in there. I don't know yet. I'll have a think and see what makes most sense depending on where we want to go next. And yeah, so thank you very much for watching, guys. I really hope you enjoyed that. Thank you very much for your support so far. If you have any ideas or something you'd like to see that kind of makes sense, let's not go too much off piste. If you know, suggesting we do a first-person shooter or something like that straight from where we are now might not make a lot of sense, but if there's something you guys would like to see next, then definitely throw that out there if it involves adding on to the existing project. So thanks for watching, guys. Thanks for your support, and I'll speak to you soon.